All right, so for today's notes on geometry, we're going to be going over some of the basics with angles in geometry. So if you've had geometry before, some of this should be review. Again, we're not going to do a whole lot with geometry. We only have one little section because only a little bit is covered on the SAT when it comes to geometry. I don't think there's as much as there used to be. But everything that we'll be doing this week and next week will focus on some geometry topics. The first part that we need to talk about is lines and angles. So we're going to look at lines and angles, and there's a few things that we need to know before we talk about specific types of lines and angles. Lines and angles will be this first main topic. Now, there are some formulas that we should be familiar with. So let's first talk about length and midpoint. So there's two formulas that you need to know about when we're talking about lines. We need to know about the length of, a line, and we need to know how to find the midpoint. So we have length, which can be found using the distance formula. And the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So again, got to know how to find length, and that's by using distance formula. The second thing that you need to know with lines is midpoint. Again, how to find a midpoint of a line is going to be by using a formula that defines midpoint, which is x1 plus x2 over 2 and y1 plus y2 over 2. Now, there's also a few different types of angles that we need to be familiar with. So let's talk about measures of different angles. Measures of angles. So there are a couple different types of angles that we need to know, and it's going to be acute, there's going to be right, there's going to be obtuse, and there's going to be straight. We could also talk about lots of other things, but again, as far as the SAT goes, which is what this class focuses on, we are going to leave it to just those main topics. So we have acute is any angle that's between 0 and 90 degrees. A right angle is any angle that is equal to 90 degrees. An obtuse angle is any angle that's between 90 and 180. And a straight angle is an angle that's equal to 180 degrees. Now, there's also some angle relationships that we need to know. So let's look at several angle relationships. The first one that we're going to talk about is vertical angles. I'm going to give a brief definition and then an example of each one of these. So, and there'll be a picture to go along with the examples. So vertical angles. We're going to say angles formed by two intersecting, let me scoot that up, intersecting lines that do not share a common side. So that's a basic definition for vertical angles. Some people think of them as angles that are opposite of each other, but again, it's when you have two lines intersecting, they're going to be angles that are opposite one another. So this angle here and this angle here would be considered vertical angles. And to help us with this, I'm going to go ahead and number these. So this is angle 1, let's go angle 2, angle 3, and angle 4. Now, we have actually two pairs of vertical angles here. Angle 1 and angle 2 are vertical angles, and then angle 3 and angle 4 are vertical angles. Because again, they don't share a common side. They're formed by two lines intersecting, but again, this side is not in common with either two sides of that angle, angle 1. So again, a lot of times people think of these as opposites. The other thing that's important about vertical angles is that they're always going to have the same measure. So they're always what we call congruent. So we can also say angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Now, the next type of angle we're going to look at is a supplementary and complementary angle. So supplementary angle is an angle, sorry, is a, not an angle, a pair of angles, my bad. A pair of angles. A pair of angles whose sum is 180 degrees. Now, I'm going to do an example for that one, but I'm going to leave a little space there, and I'm going to write complementary. Complementary. And it's also a pair of angles. A pair of angles whose sum is 90 degrees. So for an example for supplementary, we're going to have two angles like this. Angle 1 and angle 2 here are supplementary because they form a straight line, and a straight line is 180 degrees. And these two must add up to that 180 degrees. You could also have supplements that aren't touching, but if they gave you measures, say this one was 45 degrees, and this one was 135 degrees, together they add up to 180. So this would be a pair of supplementary angles, those would be a pair of supplementary angles. For complementary, they're angles that add up to 90. So if you had a right angle, and you knew that was split, so that these two angles have to add up to 90. Let me screw that up again. That'd be one way of saying that they're complementary. Or if you had two separate angles, let's say I had, say this is 30 degrees, and then say this is 60 degrees. Again, they don't have to be touching in order to be complementary. Any two angles that add up to 90 would be complementary. Now, there is two other words that get used quite often and that's adjacent and linear pair. So let's adjacent. So adjacent means next to. So angles that share a common side but don't overlap. Share a common side but don't overlap. Now, there are much more wordy definitions. I'm trying to keep this as basic as possible. But two of these things that I've drawn up here could be considered adjacent. 1 and 2, 3 and 4, those would both be examples of adjacent angles, angles that are next to each other. Whereas these would be non-adjacent angles because they are not next to each other. If you want to get technical, again, adjacent angles must share a common vertex as well. They have to have a common ray, and then no inter points in common. But again, trying to keep it basic. The other one, linear pair. A linear pair is a pair of angles that form a straight line. So if we look back up to some of the previous examples, I'm not going to draw a new example for these, but a linear pair. None of these in this one are the linear pair. But angle 1 and angle 2 up here, that would be a linear pair because these two are forming a straight line. So a linear pair will always be supplementary, but supplementary angles don't have to be a linear pair. Also, a linear pair always has to be adjacent. So if you look up a definition in a geometry book, again, the definition gets much more wordy. It's a pair of adjacent angles that form a straight line or are formed by a set of opposite rays and another ray. Again, there's a lot of different ways you can define it and add more detail to this. For the diagram up here, and we could say a lot of these things are adjacent angles or form a linear pair. 1 and 4, they're next to each other, they're adjacent. They also form a straight line, they're a linear pair. Same thing with 2 and 4, those are both adjacent and a linear pair. 2 and 3 and 1 and 3 also fall into the category of both being adjacent and forming a linear pair because they form that straight line. So those are some of the basic types of angles that you need to be familiar with. The other things in this section, there are a couple of key concepts that we need to know as well. So let me move that up a little bit. So the next key concept is what we call angle addition postulate. Again, this is all geometry. Angle addition. And you don't have to remember it's a postulate for this class, but you have to know what angle addition is. So I'm just going to say angle addition. And if I drew an image over here where I had an angle with another line drawn in and call this point A, this point B, this point C, and this point D. And I could also label these angles as 1 and 2. I could say that the measure of angle 1 plus the measure of angle 2 would have to be equal to the measure of this big angle. Now there's not just one number inside here, so we have to use letters to name the big angle. We have A, B, C. B being the vertex, it goes in the middle. A and C are on different sides of the angle. So that's another way that you can name an angle. So measure of angle 1 plus measure of angle 2 has to equal the measure of angle ABC, the whole angle there. All right. Another idea or postulate that you need to know is the sum of all angles around a point. Sum of all angles around a point. And what you need to know is that around any single point, there's 360 degrees. So all angles around a single point add to 360 degrees. All angles around a single point add to 360 degrees. Again, another way to think about that is in a circle. Let me scoot that up a little bit so you can see that. In a circle, you can say that there's 360 degrees in a circle. And again, that's what this is based off of, or that fact is actually based off of this. Around any single point, there's 360 degrees. All right, the next one, parallel angles. So we're going to talk about properties of parallel lines and angles formed with a transversal. So properties of parallel lines and angles formed by a transversal. So we're not going to spend a lot of time on the idea of what a transversal is, but I'm just going to draw the image here. So I have two lines that are parallel. Now, a transversal is a line that intersects at least two other lines. So this line would be a transversal. These two are parallel. Parallel lines never intersect. So I'm going to say that, let's name these. It's going to be line M, line N, and line L. And I'm going to say line M is parallel to line N. And I'm going to say that line L is a transversal to line M and N. And I wrote those in cursive because when we name a line, you can either use 2 points to name a line or a cursive or italicized letter to name a line if you're doing it with one letter. So these are parallel, that one's a transversal. Now the angles that are formed here themselves have certain properties. Easiest thing to remember is if you have parallel lines, then you're going to have a couple different things that are congruent. So all the acute angles would be congruent, all the obtuse angles would be congruent. So there's different names for some of these angles. And if you took geometry or if you're currently in geometry, you probably know some of these other angles. So like these two acute angles are vertical angles, which we just talked about on the last page. They are congruent. Same thing down here. These are vertical angles. They are congruent. You can also say that these two, which are in the same position, they're called corresponding angles. They are congruent with each other. These two are also in corresponding angles. They are congruent with each other. We can also say alternate exterior or alternate interior angles are congruent with each other. Again, some of those words you don't really need to know, but for the purpose of the SAT, you do have to understand the fact that these angles are congruent. And then if we were to look at the other angles, the obtuse angles, they too can be congruent. So all the obtuse angles in this are congruent. And this only happens if parallel lines are cut by a transversal. So, and then any combination of one acute angle and one obtuse angle would also be supplementary. So I'm going to write here all acute angles, or, oh, let me say this first. If two parallel lines are cut by a transversal, if two parallel, that means parallel, lines are cut by a transversal, then a couple things are true. All acute angles are congruent. All obtuse angles are congruent. And so we got those two. And any pair of one acute and one obtuse would be supplementary. Any pair of one acute and one obtuse any pair of one acute and one obtuse angles would be supplementary. All right, so those are some of the properties that, again, are very important to us here. The other things that we need to talk about for geometry are going to be things like area and volume, and then other polygons. So let's see, how much time do we have? Hasn't quite been 30 minutes yet, so we still have another about almost 20 left. So let's go ahead and talk about these other ones because I wanted to try to do all the notes in one day for this. So there's area and volume, and for area and volume, I would just recommend looking at a reference sheet for those. So I'm going to post a reference sheet online so that you can plug in to, and I'm not going to be giving you guys a whole lot of problems with area and volume, but again, you'll have a couple. So I don't have it printed out right here right now, so I can't show it, but I'm going to be posting it later today. But again, for the area and volume questions, if you have any, please just look to your reference sheet. If you're in geometry right now, you're probably just about ready to start volume. You probably did area at the very beginning of the semester. If you took geometry last year, again, you're probably familiar with some of them at least. But for right now, I'm just going to say look at reference sheet because I'm posting a reference sheet for you guys on Edsby later today. And it's going to be the old geometry reference sheet from like 10 years ago. All right. The next thing, triangles other than polygons. So, sorry, triangles and other polygons. So there's a couple important things that you need to know about triangles. Let's just focus on triangles first. We need to know Pythagorean theorem. And that's the one that goes, and you can write this either way. Most people write it as a squared plus b squared equals c squared. In a lot of geometry books, they'll reverse it. C squared is equal to a squared plus b squared. Because there's other things that you can use Pythagorean theorem for when you write it as an inequality and not just an equation. But in its current setup, you can either use this to find the missing side of a right triangle, or you can use it to identify whether or not something is a right triangle. But again, this is only for right triangles. And A and B represent legs of a right triangle, whereas C represents the hypotenuse. Again, this is a leg, this is a leg, and C will always be the hypotenuse, which is the longest side of the right triangle. which will always be across from the right angle. All right, let me screw this up a little bit. Other things that we need to know about triangles: special right triangles. You have 30, 60, 90, and 45, 45, 90. All right, so in our special right triangles, a 30, 60, 90, the 30, 60, 90, those are angle measures. Same thing with 45, 45, 90. Those are angle measures inside a triangle. So we're going to start with the short leg of this triangle, which is across from the 30-degree angle. The hypotenuse will always be double that short leg, and the long leg, which is across from the 60, will always be the short leg times square root of 3. For the 45, 45, 90 triangle, since both these angles are 45, that makes these two sides congruent. So if these are both the same, we'll call those x. The hypotenuse is going to be x times the square root of 2. Now, if you forget these, you can actually use Pythagorean theorem to figure them out most of the time. So again, if you need to, refer back to Pythagorean theorem. All right. There is one other thing that we need to talk about, and that is circles. And again, there's only a little bit of circles that we're going to talk about today. There's a couple main ideas. So circles. The first main idea is you got to know what the radius, and I'm not going to write out a definition for each of these. I'm just going to draw a picture because you guys have done radius, diameter, and circumference many times before. So radius, diameter, and circumference. So if I draw a circle, then the length all the way across, going through the center point, would be my diameter. Half of that, just going from the center point to the side of the circle, is our radius. Oh, I screwed that up. So again, radius, diameter, circumference. So diameter, radius, diameter is all the way through the center of the circle, all the way across. Radius is just half the distance across the circle from the center to the side of the circle. For the circumference, the last part of this, it's the distance around a circle. So circumference like the perimeter, it's distance around a circle. And again, C equals 2 pi r and diameter times pi. For central and inscribed angles, this is probably a topic that if you're in geometry, you just covered. If you're, again, took geometry before, this should look familiar, but central angles and inscribed angles. Again, I'm not going to write out a whole definition. I'm just drawing a picture. So here's a circle. Thing you should know here is that if you have a central angle, which is an angle drawn with the vertex on the center of the circle, the angle measure of that angle will be equal to the measure of the arc that it's intercepting. For an inscribed angle, this is a little bit different. An inscribed angle is an angle that's on the circle So if they gave you an angle measure for that, it's going to be half of the arc. So the arc will be double the measure of the angle. So 2 times whatever that angle is. The last thing that we need to know for inscribed angles, for the second one here, if we had 2 different angles intersecting the same arc, so these 2, well, there's one angle. It's going to be congruent to another angle if it intercepts that same arc. So draw a second angle here, intercepting the same arc. These 2 angles are congruent if they intercept that same arc. And again, that angle would be half of this measure, that angle would be half of this measure, so they must be the same. And then finally, the last part that we need to talk about is tangents. Again, we're just doing basics with tangent. The only property that you need to know with the tangent, so first off, a tangent line is a line that intersects a circle at exactly 1 point. And if you were to draw a radius from the center to that point of tangency, then it's going to be perpendicular with that tangent line. So, and that's it. Those are all the properties that we need to know for geometry. Again, I know there's quite a few topics there. There's only a couple other things this week. This week we have a worksheet for tomorrow. Wednesday, going to be giving you guys a review worksheet, which I'm going to go over in class on Wednesday. So during the same, during my Zoom time on Wednesday, I'll be going over that. And then on Thursday, I don't have anything new for you guys. Friday will be an assessment. Again, that assessment will be open though, starting on Thursday. That's why I don't have any new assignment on Thursday, so that if you want to take it early, you can. Again, I will still be on for office hours on Tuesday and Thursday, each day this week. On Friday, same as most Fridays for this class, I'm not going to be on doing a new lesson on Friday, but if you have questions, you're more than welcome to come on and I can answer questions. For next week, again, we'll be back in SAT week. We'll be doing SAT problems related to geometry. Did either of you guys have questions? Sad that we only got a couple people logged on today, but I know when I look at YouTube after I post these, there's a few more people looking at it there, but if you have questions, this is a good time to ask them. You can either raise your hand or type it in chat. Jordan, I don't remember if I said this or not, but yes, I normally leave you guys muted since I'm recording. I leave you guys muted so that I can post these to YouTube afterwards. Any other questions? Amber, you said you're good. Jordan, are you good? Any questions? All right. Okay, so that's it for today. Again, if you have any other questions, just let me know. Again, I'm on IDSB pretty much all day on these days. So again, ask me questions there, or you can send them to me on Remind, send them to me to my Google Voice number, either one of those. I'll work on getting these notes that we just did today posted in case I went too fast for you. They'll be on YouTube probably within the next hour. I gotta save this video and then post it. So have a good day. Thank you too for coming on, and hopefully we get some more people next week, all right? Or on Wednesday.